I was scrolling the internet to find new AI developments and came across a cool research paper that was submitted to a website called arXiv, which is an online archive of research papers in physics, mathematics, computer science, and other fields. The title of the scientific paper that catch my eye is Locating Hidden Exoplanets in ALMA Data Using Machine Learning. What this basically means is that with help of AI and a telescope called ALMA that observes radio waves from space, it located a planet that orbits another star than our Sun. So let's dive into the details of this paper. A research team at the University of Georgia has discovered a new exoplanet using machine learning tools. This is a significant milestone, as it demonstrates the potential of machine learning in accurately determining the presence of exoplanets by analyzing protoplanetary disks. These disks are essentially the gas surrounding newly formed stars and may give birth to planets. This discovery is just the first step towards using machine learning to identify overlooked exoplanets. The models used in the study were able to detect a signal in data that had already been analyzed, finding something that had previously gone undetected. This highlights the potential of machine learning to speed up analysis and improve accuracy in identifying important information in the field of astronomy. Now, you might be wondering, what exactly is machine learning? Well, machine learning is a subfield of artificial intelligence that gives computers the ability to learn without explicitly being programmed. In other words, it allows computers to recognize patterns and make decisions based on the data they're given. To better understand how machine learning works, let's break it down into its core components. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Each type has its own unique approach to learning from data. Imagine you want to teach a computer to recognize different animals in pictures. How would you do that? One way is to use supervised learning. In supervised learning, you give the computer a bunch of pictures that are already labeled with the names of the animals, such as cat, dog, bird, etc. The computer then learns to associate the features of each picture, such as the shape, color, and texture, with the correct label. After the computer has seen enough examples, it can start to guess the names of new animals that it has never seen before. That's how supervised learning works. You teach the computer what to look for and what to expect from the data. Now imagine you want to find out what kind of customers visit your online store. You have a lot of data about their purchases, but you don't know anything else about them. How would you group them into different categories based on their behavior? One way is to use unsupervised learning. In unsupervised learning, you don't give the computer any labels or outcomes for the data. Instead, you let the computer figure out the patterns and structures within the data by itself. For example, the computer might notice that some customers buy a lot of books, while others buy a lot of clothes. The computer can then cluster these customers into different groups based on their similarities and differences. That's how unsupervised learning works. You let the computer discover the hidden information in the data. Finally, imagine you want to make a computer play a game like chess or tic-tac-toe. You don't have any data or rules for the game, but you have a way to tell the computer whether it wins or loses each time it plays. How would you teach the computer to play better and better over time? One way is to use reinforcement learning. In reinforcement learning, you don't give the computer any data or labels for the game. Instead, you let the computer learn by trial and error. The computer tries different moves and actions in the game and gets feedback from the environment in the form of rewards or penalties. For example, if the computer makes a good move, it gets a positive reward. If it makes a bad move, it gets a negative penalty. The computer then learns to repeat the moves that lead to higher rewards and avoid the moves that lead to lower penalties. That's how reinforcement learning works. You let the computer learn from its own experience and feedback. So, how does machine learning fit into the world of astronomy? Well, the field of astronomy generates massive amounts of data, and it can be challenging for researchers to analyze all of this information manually. This is where machine learning comes in. By using machine learning algorithms, researchers can quickly and accurately analyze large data sets, helping them identify important information, such as the presence of exoplanets. In the case of the University of Georgia's discovery, the research team used machine learning models to analyze data from protoplanetary disks. These models were able to detect a signal that had previously gone unnoticed, leading to the discovery of a new exoplanet. The planet is circled in white. Machine learning models can also help astronomers classify exoplanets based on their properties, such as size, mass, temperature, atmosphere, and habitability.
A planet passes in front of a star, you can imagine that the brightness of the star decreases a little bit. We found hundreds, if not thousands, of planets that way.
But part of Jason Terry's graduate work at UGA was to develop a machine learning image recognition model trained to look at those pictures taken by the ALMA telescope in Chile.
Once we feed the images through the model, we have it determine whether or not there's a planet and ask it to give us an indication as to where the planet is.
Their model worked.
It was sort of an accidental discovery, and that kind of made it all the more exciting. It was strongly confident there was a planet and highlighted a very specific region that turned out to have a very characteristic signature of a planet. This is just the very, very beginning. We set out to prove that machine learning has a place in these sort of observations. We've demonstrated now that machine learning can, one, recreate previous discoveries, and two, can find planets and data that's already been thoroughly analyzed. This data that we used in order to find this planet, people have pored over it for years.
This can help astronomers understand how exoplanets form and evolve, and whether they could support life. It can help astronomers explore the vast and complex universe with more efficiency and accuracy. Machine learning can also enable new discoveries and insights that would otherwise be impossible or impractical with human analysis alone. I think this discovery is just the beginning. Keep looking up. Maybe you will uncover a new galaxy.